Greetings y'all, it's time for a short video to showcase the use of a 3D printer to solve a home improvement problem. Now, this particular project may not have direct application for your personal situation, but we hope you'll find a little inspiration from the solution we came up with. And if you don't currently have a 3D printer, it may give you more incentive for getting one. Printable Science presents the 3D printed LED string solar panel mount.
This video has been made possible by the generosity of our patrons and viewers like you.
We moved into our current house about 3 years ago, and at the time it boasted a rear deck that was a great feature of the property. There was a trellis over the deck and a grapevine beside it that blanketed the deck with beautiful greenery through the summer months and provided effective shade from the sun. A year after we moved, I got a hold of one of these LED string lights and ran it over the branches of the grapevine over the trellis, and that gave us some attractive, kind of magical lighting in the evening. Unfortunately, as beautiful as the deck was, most of the lumber was rotten, and it was obvious that the whole deck needed to be replaced, so down came the lights, down came the grapevine, and down came the trellis. It was also a bit of a drag that by the time the builder could get around to replacing the deck, it was already midsummer, so that the grapevine had already exhausted itself throwing out new branches. And so while we had a new deck, it provided none of the protection and shade we'd fallen in love with. So I cut back the grapevine, and then I began to worry. This spring I began to fear that maybe I'd been a little too aggressive and perhaps I'd killed off the vine completely. So for a few weeks I was doing a daily inspection and getting more and more anxious that maybe I'd gone too far. Well, about a week ago I was rewarded with the sight of a first bud, and over the next few days more and more buds appeared, and I'm now confident the grapevine will be providing some shade for the summer. Of course, now that the grapevine had reported in as ready and active for duty, it was time to consider replacing the string lighting. Now, the first set of lights I had were just kind of thrown over the trellis, and the solar panel itself was just hanging over the edge of the side of the deck, which was far from a satisfactory solution. But it's not as if these string lights provide a lot of mounting options. They usually consist of a small plastic spike that you're supposed to push in the ground and then press the barrel of the solar panel mount into it. Of course, that doesn't work well with a wooden 2x6. So it was simple enough to design up a mount that hugged the sides of the 2x6, provided a couple of holes for screwing it into the wood, and provided a friction fit connector that mirrored the functionality of the spike that came with the lights. The only challenge was figuring out how to design the friction connector as part of the mount, given the otherwise impossible geometry of the finished part with a 3D printer. And so I opted for a two-part construction with a printed piece that serves as a saddle to sit on top of the 2x6, and then a second piece with just the friction mount. Then all that was needed was to put the holes for the screws in the saddle and mount up the plate that lined up, and then simply assemble the full mount with the plate pushed up from the bottom so the friction mount pokes through. Now that'll get you through fine if you're only needing to use one LED strand, but I also wanted to mix a bright white strand with a warm white strand, and I decided what I really wanted to have was a total of 4 strands, which may turn out to be overkill, but nevertheless it was back to the drawing board. Now, it wasn't all that difficult to scale up the mount to handle 4 panels, just to make the plate larger with the mount posts spaced horizontally so that no panel will interfere with the other, and making the back 2 posts high enough so that when the solar panel in the back is mounted, it will not be obscured by the panel in the front. So here we have our finished panel. It has the saddle piece that slips through the post piece through some knocked out slots. And there's holes for the mounting screws in both pieces that line up when the mount is assembled so it can be screwed into the 2x6. And I'll just do this now, but I dropped a screw and I got to go down there and get it. So we just, take a screw. I don't think that puppy's going anywhere. And it's as if we're talking about hurricane force winds. And then we just, with the mount plate itself mounted, then I can add the posts for each of the 4 LED solar panels. With that all mounted, I just have to take each of the solar panels and put it on. And with, it might require a bit of adjustment, but we can turn these so that they capture the light at the best exposure, and there you go. So there you have it, a 3D printed custom mount for solar light strings that'll gobsmack your friends, annihilate your enemies, and get you the neighborhood eco-friendly nomination that you've been pining for all these years now. Take care and be safe. We can all get through this together as long as we're apart. This project requires a minimum build volume of 110 millimeters by 115 millimeters by 130 millimeters. It was printed with a 0.4 millimeter nozzle, 2 perimeters, 2 bottom layers, 3 top layers, and a 20% infill. It was printed in PLA, which is not recommended for exterior use, but if the part fails prematurely, it will be simple enough to print off another one. If you have a more demanding environment for where you would put this object, then you should probably investigate ASA as your filament of choice. In the video description, you can find a link to where you can download an STL of this project, and Printable Science supporters are reminded that you can order up custom files for this and other projects that exactly meet your requirements. Thanks for watching, and I hope you'll keep in touch so that you can stay on top of all the neat projects we've got coming up. As always, we invite you to visit our website at printablescience.com, where all the science that fits, we print.